It's getting recorded. Hello. Am I audible?
Yeah.
Yes.
Yeah.
Okay. Yeah, we can start then. So our first question was like longest uncommon subsequence. We are given a list of strings and you need to find the longest uncommon subsequence among them. The longest uncommon subsequence is defined as the longest subsequence of one of these strings, and this subsequence should not be any subsequence of the other string. Okay. And definition of subsequence is like it can be derived from one sequence by deleting some of the characters without changing the order of the remaining elements. And any string is a subsequence of itself, and empty string can also be a subsequence of any string. And you'll be given input list of strings will be given, and output needs to be the length of longest subsequence, and if not found we need to return -n. So here you can say your longest substring will be of length 3, and that's the output. And constraints are like length won't exceed 10, and the length of the list will be in the range of 2 to 50. There are any queries in this or any approach? Anything?
So I think we did something similar, easy question, couple
Yeah.
of minutes ago. There only we have two strings, and if the logic is if they both are same, then there's no answer. Otherwise, take the maximum length out of two strings.
Hmm.
But now here there are more strings, so I was thinking like could we use a map or something to find out which are same and then find out which is the largest string.
Yeah, makes yeah, it's going correct. You want to share? Like,
No, I don't have a solution.
Okay.
Just a thought.
Yeah, you'll use map to track if duplicates. I mean, should be only one, should not be duplicate repeated once.
So if we get a duplicate, that means no answer.
No, if you get the duplicate, you have to remove them because you need to take care of only like ABA is occurring 2 times. So you need to take only once that ABA, the other one will remove out.
But if I have only ABA,
Then it will be 3 only. Remove the we'll take only ABA and answer should be 3. Because empty string they are telling no that empty string is a subsequence of also any string, and a string is a subsequence of itself. So ABA substring will be ABA only.
okay.
Yeah.
So in the first, you get an output of 3, right? So we remove the first ABA, the A's are removed, and the last A is considered, right?
I didn't get once more.
I mean, how this 3 came, can you just explain once for the first example?
Yeah, because none of the strings will match with your this. I mean, let's say first you take A, it won't match with any of your, what do you say? It should be common in all the 3, right? At the first string. B also won't match like that, and secondly A also. That's why we got 3.
So A should be common to the entire string, not even the subset of it, right?
Yeah.
Okay.
So if we have like A, and the second string is A, then that's the answer will be -1.
You have triple A and single A. Yeah, it should be -1. No, but the second A is a substring of a subsequence of first A, right? You'll have 1, I think, answer. Why -1?
No, yeah. So we have
Long.
the first string we have 3A, in the second string we have 1A. So
Yeah.
what would be the answer?
1 it should be.
But we are finding the uncommon.
Sorry, yeah, uncommon. Sorry, I was saying common. Yeah, -1 it will.
If it's A, B, C, and A, so even though one character is matching, the result will be 3. Is it?
Yeah.
So the whole string has to match exactly the other string. Only then it's called common.
Yeah, whole string will match, then only it will be common. Because if any of them is missing or uncommon, that means the entire thing will be uncommon. Because if ABA and EA, if you take A is A matching, but entire one is not matching with this, right?
Yeah. Okay.
So I just quickly check a test case. Like if I have only ABA, then the answer is -1.
Yeah, if both strings are matching, but if few characters are matching, then we need to return the like unmatched characters, I guess. That was the subsequence definition says. If it is like ABA and AAA, then I
Yeah.
think the answer should be 1, I guess, because there is one unmatched character.
BA from first string B and from
Yeah.
second string A. Yeah.
Yeah.
Mm.
I'm thinking like that.
You can check.
I didn't quote it, sorry.
Okay, let me check it. What are you saying?
ABA and AAA.
Triple A, you're saying, right?
Yeah, double quotes.
I think the answer would be 3 only.
Oh, I think
You
double
need to
quotes.
put double quotes here.
Yeah. No, no, okay.
Why 3?
Yeah.
So it goes back to the same thing which we did a couple of days ago, the easy
Yeah.
one. So because here we're talking about the subsequence. So the subsequence could be of in any order. And we want a longest uncommon subsequence. So if there is anything uncommon, and in between there are common things also, still we want the subsequence could be like entire length.
Until and unless they are totally equal.
Yeah, totally equal.
If, then only you'll have -1 in that case.
Because then it could not be, they both are equal. Nothing can be a subsequence of any other thing.
Yeah. If even one character is different from the other, it will be entire. It will take the length of string. Like here, first
Yes,
is matching
because we
with
are
this.
talking about subsequence. We are not talking about like subsect or substring.
Yeah.
So if the length of the string are different, then they definitely, oh no, if they're different.
If it is different, let's say first length is 3 and second length is 5, then 5 can never be a subsequence of first, right?
Yeah, so we return the longest one, 5.
No, you'll return minus false. It will be minus. It should be -1. No.
No, in that case, it will be 5.
It'll be
Even I
5.
was having hard time understanding that.
Oh.
But
So I think like all elements, all the strings, whichever are equal, just remove them, and just whatever the last one, whichever is the maximum length, return it.
So
What
here
would be the
first,
answer if it is the smallest subsequence in the same question instead of longest?
the smallest uncommon, right? That would be 1 because B is the only thing which is not matching with any of the second.
confused. But the subsequence definition says different thing. Like a subsequence is a sequence that can be derived from one sequence by deleting some characters without changing the order. I'm confused with that. This is
Yeah, so
characters.
they are looking for an uncommon subsequence. That
Yeah,
is what is throwing people
B.
off. So
yeah,
subsequence itself is a little unusual topic. That is, you just go in the same order, but you have an option of picking a character or not picking a character. And
yeah,
then you also need to make sure that it is those subsequence are not present in any other string in a subsequence form.
Yeah, so each and every string you need to create a subsequence. Okay, and if you just put it in a map, and if the occurrences are more than one, just remove it. And whosoever occurrences are only one, but it is the maximum, then return it, right? That's the only definition. That is what it looks like. So problem statement and the actually implementation may not really looks like they are matching, but that is what it is, I think.
okay.
Okay.
Yeah, this question also has a lot of dislikes.
Yeah, around 500, above 500. It's.
Yeah.
Shashank, I pinged you one test case.
Yeah. Let me pass that. Let's see. So, what do you expect the answer to be like here?
So the first two are not considered.
Mm.
So I think ABC should be the one.
No, one will be removed, right? Or both will be removed. Like first and second are similar, right? So we'll take care of one only, and the other will remove, or both will be removed.
Yeah, both will be removed as well as ABC will be removed. CB will be the answer. Yeah, I think so.
Oh, hold on. Why ABC will be removed? It is not a subsequence.
It
Oh,
is
yeah, it was a
string of the
subsequence.
other, yeah.
Yes.
Yeah,
Yep.
yeah. Mm.
Yeah. So create all the subsequence in a map, and actually whoever has an occurrence more than one, ignore them, and whichever has occurrence only one but the maximum length, return it, right?
Yeah.
Why we didn't consider ABC? Because it's part of AABPCC.
Yeah, the previous subsequence.
Okay. So here what I did is like this is a definition for calculating the subsequence. I'm checking if length of A is greater than or even equal to B, return in that case false, and if it's similar, just increase the I else J. Moment you reach to the end of a string, first string, it will return true or false, whatever. And this is the map that I've created out of all the strings, and I'm keeping only those items I'll remove all those items if it is greater than one, else uh, I'll keep it in this check array. Now next I've sorted it from in a reverse order from largest length to smallest, and if that is not in the exclude this array, then we just need to return from the first. You just return the length of first item from here. Else for every string in check and we'll check that in the exclude whether that is a subsequence or not. So we are passing this to in the subsequence function, and it will return from here whether it's a subsequence or not. And then if it is, we append to this and come out of the loop.
What is the cow? The cow is the number of duplicate.
Yeah, it will calculate like here in this string ABA is present only one. So corresponding to this key, this as key, your value will be one. It's like this.
Oh.
This is the, for this string, this, it will be this. And your exclude will consist of only those which are having, if it is, I'll print it. This is only if it's greater than 1, it will contain that, and remaining will be put into the check array. That is CB and ABC will be put into the check array.
So you remove the duplicate. I mean, remove one of the duplicate.
Yeah. If it is 2, I've removed one, and I think the check should contain. No, I removed, if it is number is greater than 2, like it's count, I removed both of them, and the remaining one I took.
Yeah, so I'm missing the step where you are still keeping that AABBCC to see if the other strings in the check, they are looking at the removed ones for subsequence. Yes. You have exclude for that?
Yeah, I have this one. If there are no items will be there, then you have to return. If it is not present in the exclude, you return from check the first array's length, you return it after sorting in the reverse order. Like once you sort that check, ABC will come and then followed by CB. By lengthwise, I'm sorting.
Yep.
Mm-hmm.
Yeah, this is nasty.
Yeah. So I think there has to be. Yeah.
You let's say if it's not in the exclude, you return the first one, the longest one, right?
Yeah.
But then why don't you also remove the one with duplicate length?
Duplicate length I've already removed from. No,
why would you remove duplicate length if you are at the highest length and there are, for example, 3 duplicates of the same length, and if the first one is not equal to any of the rest of the 2, then that first one becomes your uncommon subsequence of the longest length.
No, after he already removed the duplicate, right? And then also remove the.
I think he's doing that. Yeah.
Yeah, you'll have this one.
So can you do one thing in that? Oh yeah, you removed it. Okay. Yeah.
Yeah, any queries in this?
Yeah, only the problem statement is a big query.
Yeah. Yeah, that's I think
I can share a Java solution. It took me a long time to get it right if people are interested.
Sure. Go ahead.
Give me a moment. Okay, let me know when you folks can see the screen.
Yeah.
Okay, so similar approaches. I'm sorting the array with the length as my comparator. So here at the bottom, I just added a comparator. So once I sort this, I'll have the highest length at the top. and then I'm iterating. So the approach which I have taken here is that if so at any given length, at any given string, I would first try to find all the strings of the same length. So that is what these two while loops are doing. So it is going left, it is going right, and then finding me the window where all the strings with the same length are present. That is the string I'm looking at. I'm just finding its neighbors. And since it is sorted, this linear search will find that for me. And then first I'm checking whether this given string is unique at its length. So I have written a helper method to do that. That is, I'm giving the index to search for and the start and end. So it will just go through the start and end, and we'll see whether this particular string was unique at its own level. If that was the case, then I'll go and see whether is this particular string a subsequence of any of the strings which are longer than it. So want to make sure that the string was unique at its own length, but it is not part of any other string at more length. So there is another helper function which just checks that starting from 0 index to the start and see whether it is subsequence of any of them. And if is, yeah, I think I should just rename the method name because it should be the other way around. But if it is not a subsequence of any of the strings which are longer than itself, then I would just return the length of that string. And I'll keep iterating and return -1 at the end. It is not very straightforward, so it took me a lot of attempts to get this right. So please ask me any questions if you have, and I can show you the code as well.
So you sort it, and then let's say the last string is only one character, or maybe two character. Then now you have to compare that last string with all the previous string, which have longer length than that.
Yep. Yeah, and I was, to be frank, very hesitant with this approach, and I was trying to find any other optimized ways to do it. But if you look at the conditions here, right, that the number of strings, the length, the given strings length. So yeah, we only have 10 strings, I guess, which we are going through. So maybe it is fine if we like go again and again and check. So it is eventually becoming an n square, and if you consider the lengths of the string as well for all those is subsequence operators, then it is you need to account for the length of the string. So n square into the length of the string.
Go down so the entire. Like one substring the length, that function is also O.
Sorry, your voice is breaking. Which function is OFM?
This function is given string in given range.
Yes.
And you can always like keep a set.
Yeah, here I think there is a scope of optimization. That is, I'm creating this set again and again for the same level. Instead, I can just save for the each level and then just compare. It was just that I wanted to see for this particular index to check for. So this sounded easier to code and like easier to understand. But yeah, there is a scope of optimization. But yeah, that is the same lines which we were talking about, and it took me multiple attempts to get this right because understanding question itself was very tricky. Like after looking at the failed test cases, things were becoming clearer.
Mm.
Cool. Any further questions? I'll stop sharing if not.
Yeah, please share this code on the Slack if possible.
Yeah, sure. I'll just share it with Pastebin. Okay, thanks.
Oh, thank you.
No, I think we can go for the next then. This one, unique binary search tree. So an integer n is given and we need to generate all the structurally unique DSTs that will store the values of 1 to n. So for the corresponding this 3 as I input 1, 2, 3, these are the 1, 2, 3, 4, and 5. 5 structurally BSTs are drawn. So yeah, they are given output in the form of this list. Yeah, all of the trees, list of list. And yeah, any approach in this?
One way is to go recursively and find, like, take a node, find for that node all the left subtrees and all the combinations it has, and similarly for the right subtree and all the combinations of it has.
And multiply both of them.
No, they have asked us the string, so not the number. They are wanting the output as vector. I mean,
Yeah,
so I have a code with that. If you want, I can share it.
yeah, sure.
So yeah. So here what I am doing, I'm starting from, this is the main part of the code. So I'm saying this is a helper, sort of helper function. I'm sending 1 comma n, and let's suppose for what we have to do, for 1 we need to find all the subtrees it has on the left side and on the right side. For 2, I need to find all the subtrees it has on the left side and the right side. And for 3, I need to find similarly. So we need to make each number between 1 to n as a root first of all, and we need to recursively iterate and find out the different combinations, so that I'm storing in a vector of tree node left and right. And let's suppose my I is 2, so I'm then combining the left and the right to form one tree, like iterating over these two for loops. So if they are 2 in both way, then it's like 4 total combinations we'll get. So yeah, it's been stored here. Uh, any questions?
So explain it again from line number 27.
Line number?
27.
Yeah. So let's
So
suppose.
you select you selected all the possible potential routes, and then
Mm-hmm.
that part from line number 27.
Okay. So let's suppose for uh, yeah, let's suppose for 1. So what we have to do? So the left side of 1 will always be null since we don't have any left subtree of 1. Agreed. So we move to the right. So in right, what we are doing, we are forming a, a sort of subtrees which can be formed like 2 and 3. This is one of the subtrees, right? And then 3 and 2. So these two are the possible subtrees which can be formed out of your on the right side. And then what I'm doing, so in the left I don't have anything. In the right, first I'll have 2 comma 2 3. Like 2 will be the root and 3 will be the right child of 2. Then what I'm doing, I'm making a I that is my 1. I'm iterating it from 1. So first of all, I'm making 1 as a root, and then I'm doing root dot left equal to L. So in my left, I have null, since we can't have anything in the left. And in the right, first I am attaching this node to that root, right child of the root. And similarly, I'm iterating it over again and finding out that if I have anything else, then I have, uh, I'm sorry, it will be 3 comma 2 will be this side. Yeah, 2 will be this side. So then I'm again making the right child of, making 3 comma 2 as a right child of 1. And then again I'm going for 2. Now in next to what I'm doing, I'm sending this left child. So it will go from start will be 2. Yeah, so it will find all my left subtree from 1, like 1 to less than 2, and right subtree from greater than 2 to 3. So if we could take a bigger example, in the right subtree, if we have given n to 5, it will go and iterate over, like give me all the combinations of subtree in the right from 3 to 5 if we are taking n as 5. And again we store all these subtrees, like recursively we call, then we go down. And so that's why I have written all these C outs and all those right call, left call, like I was checking it in that way. And it I mean, in this way I'm doing it.
So every time you take one element, right? So the way
Yeah.
you're putting like from 1 to n, so you start with first, and then you find whatever the left and right subtrees are for that one, and then you
Yes.
combine that in your for, the double for, right?
Yeah, right.
Okay. But I was slightly confused. If you go up,
Yeah, sure.
here when you say start is greater than end, yeah, that is right. This condition is the base case. But why are you actually inserting here null?
So if you see in the output, right, so let's take the first output here. So whenever you see here that what they are doing, how they are printing, whenever you have a element in the root, so let's suppose you don't have the left child but you have the right child, so they are printing as 1 null 3 2. So I need to print this null in the output.
So you are
So
the
they're
first.
not.
Okay,
Yeah.
okay, got it.
Yeah. So they're not considering the right child to be null, like they're not printing for that. But like if you have anything after that root, like in this case, let's take the last example. So 1 null, 2 null, 3. So I need to store that null so that I can print. I mean, if in that case if they are not printing in this way, we could have directly like return or something.
I think even that they still need to return no, right? Because there's a left. Let's say in this case, the left child of 1 is no, then where you put no there? What else can we put? There's only 3 cases, right? I mean, put the 3 node on no. And if we have nothing, we just put no there.
I think that might give you a garbage, right? If you don't.
Because he is returning the vector of tree nodes, so then therefore he has to put that null in that and then return.
Yeah.
So any further questions or any other approach? I think this can be yeah.
Sorry,
yeah,
would it, if we, is there any, I try to look, but I don't see that there's no overlapping subtree. right? Is there could be any overlap?
Yeah, they can be. Yeah, there can be. There is actually, and we can, I think, solve this by DP2. But for me, thinking about that DP process, I didn't, I couldn't think about it. I mean,
But I
I can.
don't think so. It should be a overlapping, right? Because every time what we are doing, we are splitting. Like if it's 1, 2, 3, we are splitting every time. Like taking first one, and then splitting left and right subtree. Correct.
Yeah,
So
but
left
like
subtree is
if you,
null, and right subtree will be 2, 3. So if you go to 2, it will be again left will be 1, and the right will be 3. So
you can have, I think, at times.
yeah, I
really,
mean, if you go and draw the recursive tree, right, like which I was doing,
Yeah,
so we'll find that they are overlapping. Uh,
sub
like we are
problems will be
calling
there.
to, yeah, overlapping sub problems will be there, and we can make this as a DP. I don't have any drawing board to show you as such. I was doing in pen and paper, but they are overlapping. Like I was finding that we are calling like 2 comma 1 or 1 2 comma 2, and then again, since we are going for 2 comma 1, like they are overlapping sub problems.
okay,
I use DP only.
okay.
So you have used, okay,
Then
okay.
yeah.
If there's overlap, I think we can create the type like the hash map
Memoization.
to like we don't need to go over to create that again, but we can clone it, right?
Yeah,
Mem-
copy, huh?
yeah, memorize. Yeah, we can. Yeah,
Hash map memoization only, no?
Yeah. Hash
Yeah,
yeah,
map.
yeah.
okay.
We could have. But like it took me time to just come across the solution, so I just left it. I'll probably try.
What would be the runtime complexity of this solution?
It will be since it's a binary search, 2 to the power n only, I guess.
No, two array. No. First element you are taking from left and checking for all the right. So it should be order of n square.
So, but again, we are going down and making all this subtrees.
Now, let's say one you picked. Now you'll try to check all the possible subtrees that you can form from after one, the elements after one. I mean towards the right. So for
Yeah,
each element you will do that. So should be order of n square, right? Or I mean it will not. I mean should be like.
I mean, let's suppose you went to 5. So first you are starting from 1 anyhow, and you are
Yeah.
checking for 1 to 5. So for n, you are going and recursively creating a subtree on the right side from 1 to 5 all. So in that case, if you see that, I guess 2 to n will be only n.
But it should be t of left into t of right, right? For every node. Let's say 1 to
Yeah.
5 you have. Now 2 is, let's say 1 to 5 you have nodes. Now let's say
Mm-hmm.
2 pick as a root. Now you will calculate all the subtrees that you can form on the left side, all the subtrees that
Yeah,
you can
yeah,
form on the right side. And
I agree.
you'll
But let's suppose if you're considering 1 as a root, and then if you see in the worst case,
mm,
I mean, then
then
only
it
you have to go from, yeah.
t of 0 will be on the left side in that case. That is, you don't have no nodes. You have 0 nodes to create anything.
Yeah, so that's what in the right we are creating everything. So that's
How?
why yeah, that's what I'm coming from. Like the right you have to
But,
create everything anyhow.
but
Then you consider 2 at the root, and then you like do it all over again.
Yeah,
So it have to be more than n square.
right.
why dp will come then? Okay. This is the sub problem of the unique binary search tree, right? One in which we have to just print how many structurally different you can create.
Yeah, that
This
is
is two
Catalan
unique
number we are printing.
Catalan number, yeah. From that
Yeah.
only I'm seeing. Yeah. That Catalan is that only 2n upon n plus 1, right? So
Yeah, but that's approach that we are only just calculating the number. I mean, I get your point, what you're saying using the formula, but
yeah.
here we have to print everything. So we have to visit every node. So there we are making some like mathematical computations and coming across that. I mean, that's what I am thinking might be true, and anyone might comment anything.
You click on solution. I think they should. They might show time.
You're sharing a solution?
No, that after description, the solution tab is there. No, in lead code itself.
Oh, but there's it's like
They give at times time. Okay,
it's like
okay.
locked.
Leave. Okay.
Any further question?
Is there a conclusive way of determining the number of trees which we'll be able to create?
Yeah.
Yeah.
It's like go for every node and check how many trees you can form on left and how many you can form on right. So those many, let's say three trees you can form on left and five on right. Then 3 into 5 corresponding to that node, 15 trees you can create.
Oh, and then sum all of them.
Yeah, sum all of them. Then go for 2. Then again, whatever like x you form on left, y you form on right, x into y. Those many again possible combinations are there.
I see.
Yeah.
There's one question.
And they will be structurally different. Yeah. Go ahead.
I think there's one unique binary search tree one, I guess, for that.
Yeah, that is.
A unique binary search tree one, where you have to only find the number of different binary search tree we can form. That is done by the Catalan number. And this question is just an extension of that, where you need to print everything, whatever like different subtrees we are getting.
Got it.
Stopping my share.
No. So with DP is like this. This is just checking, like if you don't have anything on the left of it, then in that case it'll return none, as per the whatever Saurav was saying, like the to follow the structure given by the lead code. And this is just the memoization part. You're checking if it's already present, pick it from there. Or the whatever concept he told, I'm creating I'll go from start to end of all the nodes, considering every element of like from 1 to n, every element as a root, and calculate the list left one and the right one, and just check how many trees you can form on the right side from this, and just store it in your what do you say in the memoization table. And whenever you find, next time when you go, if you find that you have already computed, is just take the value from here.
So it is almost a similar implementation, right?
Whatever it is, Saurabh was saying. Yeah.
So is it the time complexity is something to 2 raised to n?
Here he is using memorization. Right?
The memoization will be lesser, but if it is not memoization, just the recursion.
Yeah, 2n. Yeah, 2 to n.
Yeah, 2 raised to the power n, right?
Yeah, in the worst case, 2 raised to n.
Yes.
Because the Kaplan's formula, even if you simplify it, it will be like that only. 2 raised to power n something it will come. It's in some factorial it will come, n factorial, something like that, or not sure exactly.
But he did not use any memoization, right? So still he could pass through.
Right? Yeah, that was the best part. Yeah, but
you used memoization, so
what
maybe
getting
much time.
Mine was like, sorry, submission. Oh yeah. What was your times? I think, but it will be different to language, right?
Like for C++, it was 32 milliseconds and 14.1.
Yeah, it's almost similar, right? So
language
difference is all same, I would say. Whatever language it is.
Any queries here?
Yeah, no queries only, but only about the memo version, whatever you said. So I think it might work in your case also without the memoization, right?
It should work, yeah.
I'm not saying you have to do it because you'll have to change everywhere. So
Yeah.
it might work.
I'll check it.
Yeah.
Because his was working without memoization, so.
Right.
Can you explain those two for loop for left and right? I mean, in a visualization, like if you can take the numbers and then see how it goes.
Yeah,
I'm
sure.
confused there.
Yeah, sure. So I think it's a recursive one. So list left your will contain. Let's say you'll start from 0th and your numbers are like.
So take the same example. What is there, right? 3. So 1, 2, 3. Yeah.
Okay. So initially your start is 0, right? And your this is, let's say, I think I have made something should be end, right? I think it won't run this code. Oh, it's running. Okay. So this is now what you'll have. Your start is 0 and your root will be this will be -1, right? So your start is what you're saying. Your end is less than start. That means you don't have anything on the left side. Like you're starting from 1, you don't have anything on the left side, right?
Yeah.
So in that case, it will return none, which because you don't have anything. Next, you'll go to the right one. You'll check for the root +1. So your root +1 will be now 1. This value will be 1, and your end will be
3.
Sorry, your end will be 3. So 1 to, so I have to take the diagram. Wait.
So root will be 1, right? In the first case.
Root will be 1. Because this is the root is start.
Yeah.
Root is
Start is
0, right?
It will be 1, no? Root is 0. 0 plus 1 is 1.
Yeah. Root is 0. Yeah.
So this will be your 1 and your end will be 3. So what?
It's not a root like because you're starting from start to end +1. So it should be start is 1, right? 1, 2, 3. That is the only values you have, right? So root should be first as 1, no?
Can you show the start and end initialization?
Your start is 1. Oh, I'm starting from 1.
Yeah.
Okay. Yeah, that makes sense.
Yeah.
I thought range starts from 0. That's why I was thinking.
Yeah.
No,
it's not 0 base. Yeah, you're right. Yeah, just go with that.
Should I proceed?
Yeah.
Yeah, let's see. So, I mean, I got confused. So initially your start is 1. It's a recursive. Let's say yes. Start is 1 and your root will be 0. So this is your end. End is less than your start, so you'll return none in that case. This is your end, right? Second one.
Yeah.
Yes, and it will return. So this first list left, it got executed. Now you'll go to the right one. If you see the right.
How did you came up with root -1? It feels like it should be end -1. I mean, when we are thinking, it feels like it should be end -1.
I have changed the variables like it was actually what are you saying? Can you repeat once more?
No, I think I got that. So no, I was thinking like why it is root -1 and not end -1. But then I got that the left tree of the root will always be less than the root. So that's why it is root -1.
Yeah.
And then the right tree will be greater than the root. That's why the start is root +1. It's like a binary. Yeah, I mean, yeah.
Yeah, the divide and conquer. Yeah, that's true.
Okay, yeah. Go ahead.
Yeah, we can proceed next, or any queries further?
Yeah, we can go to next.
Okay, okay. So this is like you have to count the characters of all the substrings of a given string. We have defined a function called countChars, which will return the number of unique characters on S. For example, if we have S is this, so all the unique characters will be returned. Since they appear only, they are unique because they appear only once, and total number of unique characters is 5. Now on this problem, given a string S, we need to return sum of all the count unique characters T, where T is a substring of S. Notice that some of the substrings can be repeated. So in this case, you have to count the repeated ones too. So this is your ABC, and all the possible substrings are this, and how just we are counting the number of letters in each of the substring, which will be equal to your 10. And which will be your 10. Okay, and corresponding to this you have 8, and here you have 92. These are the constraints, and it will contain only uppercase letters. And I think duplicates. And you have to take care that some strings can be repeated. So in this case also you have to take the repeated ones. Okay. Yeah. Any queries in this approach?
So is it asking for the permutations of only the unique characters?
Permutation you can't say because it is a substring, no.
Oh yeah, it is a substring. So, but only unique character substring.
Yeah. Permutation will be then like CB can also come here, but you won't get CB here, only BC.
Yeah.
So you have to find all the substrings first and get all the unique letters in that. So this won't be a mathematical problem at all, right?
Yeah, that's a brute force, like, isn't it? I mean, that's a naive approach. Like, we'll generate all the possible substrings and then count the unique characters, right?
But if the constraint, then
I have a feeling that it is going to be a mathematical problem.
Yeah, it's a mathematical problem.
Yeah, if you generate all of them, like it kind of ends.
But like for A, B, C, you have 10, right? But A, B, A, you have 3. So how you gonna encounter, like you have to check for duplicates also.
That
So
will be slightly difficult to do that, yeah.
yeah, that will be difficult if you go by mathematics. I mean, in that case, you can have any combination of any number. So how you gonna track? And I don't see any formula as such. Also, like ABC has given us 10. Let's suppose I don't know, Catalan number maybe 10, but then again ABA is house coming at 8. Should be like if you're, I mean, very difficult to figure it out in a math.
Yeah, and the length is also huge.
Maybe if we find all the longest substrings that have unique characters, we can start there, and then we know the lengths, so we can calculate how many possible substrings can be made out of that. For example, when it's if the length is 3 and they're all unique, then what would be the formula for
for the NCR formula? Okay, the combination one.
the combination formula, right?
Can you explain on whiteboard or something?
But if it is there, only if everything is unique. If it is
yeah.
Because if you see the string length, it is 10⁴. It means there will be duplicates. So the assumption is that.
Yeah.
So if it is only 26 characters, then at least we could assume something, right? So but the possibility in this case is slightly very low.
Yeah. But what he was saying, like if we have longest string, we can find which consists of all the unique
let's hear
characters.
what Martin was saying.
Yeah.
And then, okay, so let's say the string is length
Screen is
50.
not visible.
I'm sorry, 1 second. Let me just open. So I haven't solved this yet, but I'm just gonna demonstrate the idea.
Yeah.
Yep.
For some reason, it says page not found for the problem.
Oh yeah.
Yeah.
You have to go to what is the number?
404.
Yeah.
No,
it is 828 actually.
On
lead code, it is 828.
Okay.
Wait, I can share you the link on private chat, I think.
Okay, 828 you said?
Yeah.
Let's see. Oh, I got it.
Okay.
Okay, sharing right now. Okay, so what I was saying is, let's say, so we have A, B, C, C, M, D. Okay, so we go one by one. So we go A, and then is a unique? Yes. B is a unique? Yes. C is a unique? Yes. And then C is not unique. Okay, so now we're gonna start from this point. And this, we're gonna calculate how many combinations we can form from this. And then we do with this. C is a unique? Yes. M is a unique? Yes. D is a unique? Yes. And then from this, we do the combinations again. Is that a right way to look at this?
Combinations in what sense? Like ABC, from there you'll form A, B, C, and then A, B, B, C.
Yeah. And also, and then when we find, once we have duplicate, then we kind of start over having another substring, and then until we find another duplicate, let's say. And let's say D. So until is duplicate, until there's, let's say here we do B. Until we find non-duplicate, then we take a new string and then we go forward and do the combinations.
But then how do we combine the results?
Yeah. I think we'll accumulate
Don't we
it.
just
Normal addition, whatever combinations we get.
So this one plus this one, right? Plus DB.
I'm not sure of that.
No?
I don't think so. It is that straightforward, because then you'll have to consider the bigger strings also together, right? To find all the uniques in each and every one. So that will be a different factor you need to consider. So like first you said it for ABC, CMD individually fine. Even if you get result, you might even add or multiply, but you will still have to look for ABC, CMD together,
Yeah, but ABC, CMD.
And then you'll have to again look for all of them.
Yeah, but then ABC, CMD, if you take it as a whole, then you have, what can you form from that?
Right now, when you say just ABC, you are not even taking into account CMD, right?
Yeah.
But as a whole, you will have to sometime take that also into account.
But how can you take this as a whole when there's two not unique characters?
But then you just remove them. you know, you like if it is A, B, C, C, M, D, you drop both of them.
You can have them in the string.
Yeah. So that will keep on adding, because if there are many such segments, then you will have to do like level 1, level 2, level 3, many of the levels, and that might go on for long.
Okay. They have divided the answer by mod, that's why I think.
Yeah, so that is what it says.
Okay, I see.
It might be
so
a huge number.
Let's say you're saying if we consider the whole string and we remove this, and then this is another string that is unique, right?
Something like that, yeah.
Okay. Okay. In that case,
yeah, I think the way Shashank was describing that approach, I think that might be close. The good approach, I would say. Yeah, even if it's brute force, right? So you create individually all of these substrings.
Yeah.
And find if it is unique using in a hash set or something like that.
But the length of the string can be 10 to the 4, right? So
yeah.
we need like to select all the subsequent, we need to 2 to the power of 10 to the 4. That's going to be a lot.
So do you guys remember we had a similar problem in which we were checking the contribution of each subset? We were finding the minimum and maximum and checking that in how many subsets a given element will be minimum and how many this will be maximum, and then we'll just using that as a mathematical formula. I'm somehow thinking that what if we can use a similar tactic here and just find out that assume all the characters are unique in a string, then what will be the total number of unique characters in all the substrings, and then deduct for the duplicates ones. That is, if I have ABA for in that example, right? So ABA, I have got 3 characters. So in the all unique scenario, I would have 10 substrings, and I think we can come up with a formula to count the number of substrings with each length. So the way I was thinking was that I'll have 3 substrings of length 1, 3 minus 1 substrings of length 2, and 3 minus 2 substrings of length 3. So I'll have the count of this is how I can compute that if what is the total number of my substrings and what is the contribution at each length. And then for we'll just do a frequency map, and we don't really care about the order as well, right? So I can just sort the string and then find so in the case of ABA, I'll have AA as a dupe. So now I just have to go and find out that how many substrings was AA part of and remove its contribution.
Use screen, I think that will be better. It's like
yeah, okay, let me share my screen. I'm not sure whether this is gonna work, but yeah, let's give it a shot.
More. Hello? Yeah.
You guys are able to see the screen?
Yeah.
Yeah.
Okay, so in the case of ABC, right? So I have characters and substrings. So if I have 1 character, then the substrings are 3. If I have 2 characters, then the substrings are 2. And if I have 3 characters, then the
could you make the font size bigger?
Sure.
Thank you.
Okay. So this is how I'm gonna compute the substrings for each characters, right? And for one character, everything is gonna be unique all the time, so I don't really need to deduct the contribution. So let me actually put it here as well. I'll have A, B, and C. Here I have A, B, A, C, and B, C, and here I have A, B, C. Now let's do it for, so here everything is unique, so no deductions needed. But in the case of ABA, I can call it AAB as well, so just for my duplicate computation. Here also I can have a similar design. So 1 is not gonna change. 2, I will have still 2 substrings, and then I'll come for the discounts as well. So now I have A.
It's 3, right? When it's 2 characters.
Oh, sorry, my bad. My bad. And here AA, AB, and how many substrings will be here? AA, AB.
Should be BA.
No, BA can't be.
Yeah, that wouldn't be unique, right?
Yeah. No, anyway, substring, how can... yeah,
you can have AB as a substring, right?
Yeah.
Sorry, AA.
Yeah, AA is there, AB is there.
No, AA won't be a substring because
contiguous it should
ABA
be.
or...
Yeah.
So for one character, it should be AB, right?
He's talking about second string, I think.
Actually here, I will have like this. And yeah, in this case, we will have AB, then AA, and then BA.
No. You are actually taking subsequence, right? It is substring.
Yeah.
Let's park this. So in the case of ABA, how many substrings I can have? Oh yeah. I was taking the substring.
No, it just takes. Yeah. We had a similar problem, right, today.
Yeah.
Okay, so substrings would be AB and BA. That's all, right?
And A also.
No,
Single A is also. Oh, 2 lengths will be like this, correct. I was.
So AB and BA. Yeah, let me do that.
Yeah, correct. ABA.
Okay. So now I am actually a little bit confused because I was thinking that maybe AA will come here because I was looking at the subsequences and I'll deduct the contribution of AA. But in this case, AA, okay, if we still continue building on that thought, how many substrings is AA part of? So looking at this, we know that AA is part of only one substring, that is this last one, right? So here, whatever was the contribution of AA will be removed. So I would have assumed that, okay, it is gonna be contribution of 2 because of 2 characters, then I would just remove 2 from here and rest will be the same. And actually here also I'll remove AC because I was not doing the substrings. So this was 3 plus 4 plus 3. So the total was coming as 10 in the earlier case. Yeah. Here, we are not deducting anything here, not deducting anything here. And we are deducting 3 minus 2 here. So that gives me the answer of 3 plus 4, 7, 8. So just an idea, if we can like put this in an algorithm and find this efficiently, that what is the, how do we compute the deduction for the duplicates?
Yeah, because one thing what I think, if instead of ABA, if you have AAB, in that case the answer changes, right?
Yes, because in that case AA will be part of the substring as well.
Right. So you will
you
just
have
have
to,
AA and BA.
yeah.
So then you'll have just the answer 2 there, right?
Yes, so you will deduct 2 from here and 2 from the end as well.
Yeah. So then everything will be position dependent. So then if you have to get some mathematical formula based on the position, I'm not saying it can't be done, but it will be more trickier to do, right?
Yeah, definitely.
Yeah.
Yep, yeah, that's what I was thinking. I'm still not sure because see, creating all the substrings and then checking for the uniqueness, it's gonna be definitely crossing the time bounds.
Absolutely, yeah. And it's not even exciting to do that, right?
Yep.
Yeah, that's
okay. Yeah, that was my thought. I'll stop sharing. Shashank,
Yeah, no problem.
take it over.
But
Yeah.
that was a good thing, Bobby. Yeah, we part it. Yeah.
Thank you.
Yeah, thank you.
Cool.
I think I haven't approached this problem much. I think what Martino was saying, I don't know.
Martino's idea and Bumik's were almost similar, I would say.
Yeah.
To some certain extent, but it might be viable to do that, but we'll have to give a lot of thoughts to it.
Hot press, yeah. If somebody has some other, I haven't done this one. I was like that only brute force, like calculate all the substring and then unique characters out of it.
Oh, okay.
Yeah.
No, I didn't try this either because I thought it's too difficult. I just left it.
Yeah, it's it's like the first uncommon subsequence itself was like
yeah.
Yeah, this one longest uncommon subsequence.
Guys, do you think it'll help if we go through the string and remove the duplicate and then do the kind of the combinations, the substrings?
Let's take example from here and let's try once more if you.
No, I'm just this came to my mind. Let me see if I can. So
yeah, even if you remove the duplicates, but when the position dependency comes in, things become more trickier.
So these kind of problems belongs to which kind of category? Like none of the algorithms will work here, right? Or none of the standard algorithms.
Yeah.
Only if we are bit mathy or something like that.
I think this might be something to do with the suffix tree or so.
It looks like, huh?
I'm not sure. I'm just thinking loud.
No, it gives an impression because of substring suffix tree might be.
Okay, you calculate all the suffixes.
I put in the chat. So in this case, like let's say if it was A B C D E F F F G. So if we just remove the duplicate E's and F's and G and then calculate with this string. No.
Let's run it.
Problem.
But the main string you still will have to take it for singles. And if you go for like the length as 2, in some cases you will still need them, right? Not all cases, but still, like in case of EF.
Yeah, the EF is still there.
Okay, EF and FG will be there.
Yeah. So yeah, what you said before, like when I was taking like separately, group by group, and then you said that okay, now we kind of need to combine these groups. So I think this will solve this problem, that problem with the groups. So, I mean, I don't know. Is there any?
So you are saying just remove all the duplicates and then just use a simple the formula.
Yeah.
And then just add the duplicates when you are actually getting the ones. The substring length.
Yeah, but you don't need to add the duplicates when you're getting the ones because you already have them in the string.
No, you need to add them, right? when it's a single length, one length, length
Yeah,
one.
but all of them are here, no?
Yeah, but if it is a length one, they will all be unique, even if they are duplicates. In the case of ABA, if you split as length one, it will be ABA, 3 separate substrings. So that is the only small thing we'll have to make change there. Maybe the solution might work. Yeah.
So you're saying like this, AA, for in case of AAB, see if we do, can you say why would we add the duplicates back again?
Because if it's a single length, length one, so all will be substrings, right? The whole of it. So that's not a big thing to do. If this is the way it works, then we'll just have to add those extra duplicate numbers.
Okay.
Yeah, I think that might work. Yeah. Maybe worth trying that.
Cool.
Yeah, let's check it. I think if somebody can come up with something, can post in the Slack.
Yeah, please. Yeah.
Yeah.
Because I didn't understand the way to do it.
Yeah, it was like,
So I was trying the older way, what we did. You remember, Shashank, we had a similar problem where we used to check for each and every uniqueness of a string using a hash set.
Yeah.
I was trying to do, very big thing. Oh, I just stopped there.
I think similar to
this was more complex. Yeah. Sorry.
Yeah. I think similar to that, this we can, but adding more complexities because of duplicates.
Okay.
Let's check it, and if somebody comes, let's post it. Yeah. Okay, then let's wrap it up.
Yeah. Thank you.
Okay. Thank you, Santosh. Thanks, Martino.
Thanks, guys.
Thanks, Boom. Okay. Thanks,
Santosh. Thanks, Sasha. Bye.
Thanks.